we'll move on to the panel discussion. We'll get Bikash on stage again. So Bikash, please come. We have Vishal Patil of eInfochips as well here. Yeah, please, Vishal. Arnab, I think, should join you just after his talk on the other track. But Bhaskar is here. Bhaskar, please come. Bhaskar is the founder and CEO of Technosphere. So they're going to talk about trends and challenges in IoT security. So it's all over to you, Bikash. Go ahead.
Thanks. Next, what we could do is we can do a quick one-liner introduction and then get started. So I'll start with my one-line intro. So because Barai earlier founded a company where we use AI to automate ethical hacking and digital cloud. The company is now acquired and is part of Synopsys. So I'm Vikas Barai, and earlier I founded a company called Alchemist where we use AI to automate ethical hacking.
Hello, I'm Vishal Patil. I head the IoT and connected devices initiatives at eInfochips. So eInfochips is a company where we have anything from ASEC to cloud. We are on the device side, we are on the gateway side, we are on the cloud side, and working with a lot of customers across the globe. We have some learnings which I'll be discussing as part of this particular panel discussion on the IoT security. Thank you.
Hi, Bhaskar Rao, founder CEO at Technosphere, where we are into developing connected devices, IoT solutions. My previous background in security has been I was heading the India operations of a smart card and RFID security company, making electronic passports and DoD for security devices, etc. E-health. Thank you.
All right, and I feel like I just introduced myself 5 minutes ago. But yeah, what I didn't mention is when I'm not teaching digital forensics, I actually do a lot of work with things like hardware hacking and developing new security hardware and playing with microcontrollers and all those fun things like that. Skydiving, flying. I have now 14 or 15 aviation ratings. I lose track. I got to count. And I've done a lot of work actually in the aviation industry, including avionics and security of airliners and things like that. So.
Today, we thought of discussing two things. What is the IoT threat landscape? Understanding that, getting a broad view and the taxonomy of that, so that when we go back, we get a good idea of what are the threats and attacks in the context of IoT, number one. And number two, what we thought of discussing was what are the security controls? How do we mitigate those risks? So these are two things which we thought of. Now, before we get started, I actually wanted to ask all of you, and we want this to be more interactive. So we'll try to keep a handsome amount of time towards the end so that we can have Q&A. But before we even get started, I just thought of asking all of you, like, do you have some questions in mind for which if you get an answer today during this panel, you will go back happily? So what are some of the questions or thoughts which you have? Just questions, no observations right now. Yeah.
CIOs and CTOs, right, struggle with security. A lot of people come to us with IoT boxes, right? We don't understand how to implement it. We are a media company focusing on IoT. I'll tell you about it on the sidelines, but we don't know how to implement it because there are 10,000 people coming to us selling boxes of security. That's the thing. I don't know how to implement this.
Okay, so I'll frame the question in this way that when you are implementing IoT, how do you have secure implementation? That's a secure implementation for IoT. Yes, we'll cover that. Anything else? Hardware security methods for IoT. Okay, that's great. And
so how do we remove the gaps between the software development and the security? Because a lot of the time there is a gap which we see. The software development say, okay, I can do only this, but the security aspects are not being considered most of the time in the development.
Okay, building secure software? That's another question. So I think that's great. So we got some idea about what you want. I typically take notes. I can't see something to take notes right now. I hope we will remember all the 3 questions. Okay. So let's get started. And we will do it more impromptu. The question will not be directed to any of you in particular, but any of you can get started. So if we think of classifying the top attacks in the context of IoT, which will be the top attacks and threats, and how would you define those? Any of you can start. Yeah.
All right. Well, I guess what I would say just in general is, we're generally speaking technology people, and we love technology, and we're always looking for that magical box that's going to solve our security problems. But the reality is most of the successful attacks that we see today and have been seeing for the last 10 years are not very technical. And it's more of a human behavior problem than I think of a technical problem. We look at what's the most successful attack, and it's usually some form of social engineering. And I think that that's something we're going to continue to see. And all that's changed really with IoT is we now have more devices out there that can facilitate some of those attacks.
Yeah, I think what Phil mentioned about the scale is mind-boggling compared to what we have today in terms of computers, the number of devices, the number of areas. For example, we may have some sensor sitting in a ship, or some control logic, for a pump control, through the IoT network. So the whole landscape is very wide, and therefore the threats are also in that much potentials are there. Of course, since we are also not talking about internet on one side where data is flowing or from sensors to the cloud and back, and maybe to other servers when for analytics purpose, etc. on one side. The other side of thing is the sensors themselves are wireless. Okay, so there is another new element in the potential for attack right at the sensor to gateway. So some spoofing, some denial of service attacks, etc. can also happen at the low level. So right in the local area network, wireless network is also vulnerable. So the vulnerability is everywhere. Of course, if we see the kind of attacks which have happened so far, I would agree with Phil that they are all pretty straightforward attacks. Like some baby health monitoring or heart beat monitoring device did not have a proper password, security or a password, and therefore the password could be easily snooped and collected. Another place, there was it was running like a hotspot without a security, a wireless network operating without security for another healthcare application. So these are basically, I think the implementations have been very raw initially, and this also have come from the fact that at the device level, the amount of space available in memory or the power of battery life which we target, etc. They actually are contradictory to adding so much of security features and implementing a lot of algorithms and making the device secure. So this is the contradictions. We have to find ways to really manage these attacks.
Good, thanks. Uh, I think the taxonomy or the ways the attacks can be done also depends on the domain. So while we work with the customers, the real questions that we are getting from different customers in various domains are the key questions which the industry is facing. So we have a customer in smart agriculture, right? And then he comes and asks us, we want to develop a solution in smart agriculture, and we want to do this in an Indian situation. Now the gateways and the sensors that he has is back in a remote area. We are talking of cyber security. His main question is, if my gateway is snooped, somebody just takes away my gateway. I'm there at a very remote area. I don't know who is taking my gateway away, right? So a theft. It's just a simple theft. it has nothing to do with even the cyber security in even attacking or doing any authentication or authorization. So the case over here is just anybody taking away the gateway and using it at his pump, the usual case that you'll see in Indian scenario. You see something out over there, you just take it out. Another case can be in a retail store at the other end where the retail guys and companies are coming to us and are saying, what is happening is we are actually capturing, have some video analytics been running on within the stores, and we are worried that if this video analytics has been snooped, the privacy and the captures that we are doing for our customers can lead to millions and billions of losses for us if there's a sue that can be done or a case been filed against us. So the taxonomy depends on the kind of situations and the domains that are you looking at, and the broader the way you look at in the DDoS attacks, or in terms of what we have as a middle man in the middle, or even actually a theft is a kind of IoT solutions while you are deploying all those, these are the questions that have been asked by the customers, and we need to talk about those taxonomies and consider those aspects minutely from domain to domain.
Great. So I think what we can do, as you mentioned, that for the taxonomy, we need to understand the context. And if we think of building a threat model, see, we got these four, I think, components, right? The sensors, the gateways, the applications, and the cloud, right? So we need to look at the threats in the context of these four things. So if you have to kind of enumerate all the threats possible in this context, it's around 25,000. Probably, I might be wrong. Huh? So it's definitely a few thousand, and you can get this list of all the threats it's possible to get. And the number of vulnerabilities possible, again, is in several thousands, maybe something around 60,000. So how do I then create a taxonomy or mapping? So what I'll do is, obviously we can't cover all. So I'll give you some clues which you can go back and try it out. So one is, when we look at these sensors, so that's where somebody mentioned the hardware level attacks, etc. This comes into picture, and you mentioned that this we have got very limited resources, which makes securing a lot harder. So there are many techniques which you can do in terms of, so one is, if you have to think of the attack taxonomy over there, you can use this model called STRIDE, where S stands for spoofing, T for tampering, R for repudiation. So the STRIDE classifies the type of attacks. So in terms of the number of possible threats, all the aspects of STRIDE is applicable in this case. And the other comes, like, each of these will actually sit, you will build some of your own application, but each of these are going to sit on some operating system. So all the OS vulnerabilities will be kind of relevant. So where do you find those OS vulnerabilities? Go to NVDB, National Vulnerability Database, and there is this CVE. Okay, so for each of these versions of operating system which you are using, if you go to CVE, you can find out the list of all the vulnerabilities which are applicable. So look into CVE for finding vulnerabilities. Use STRIDE to do a threat modeling. Then we come to the applications, right? For applications, again, I think there are more than 50 classes of application vulnerabilities, injection attacks and business logic vulnerabilities, cross-site scripting. So go to OWASP, OWASP, and you will find out all these classes and listing of the various vulnerabilities which are possible in application. Okay. Now, if you look at cloud, cloud is a combination of application and operating system, network devices. So for securing that, you need to secure both the network layer and the application layer. So you got the hardware, network, application layer. So for securing the cloud, all these aspects of network vulnerabilities in CVE plus OWASP is going to be applicable. Plus, there are some very cloud-specific attacks. Those cloud-specific attacks also, you will get the taxonomy in OWASP. The IoT-specific taxonomy, again, you will get it in OWASP. So I give you some clues of where to go and find these things out. So now, if you have to understand the context of your security, what you need to do is an exercise called threat modeling. Okay, so how do you do threat modeling? Just go and Google it out. We can't probably take you through the entire process of threat modeling, but you can use these models like STRIDE and create the list of threats which you have. And then you have to go for penetration testing and things like that to figure out which are the exact relevant vulnerabilities present in your system. So this is at a high level a direction. This is probably not the exact answer which you are looking for, but the exact answer is too big. 65,000 vulnerabilities we can't discuss. But you can look into these areas. And Arnab is here, so um, so just to set the context, Arnab, we missed you. Secondly, we were just discussing on the attack taxonomy of in the context of IoT. I just spoke about that we need to break it down into four areas like these sensors, the gateways, the applications, and the cloud. So maybe I was talking a little bit about the taxonomy they all covered. Before I kind of cover the rest of it, maybe let me ask you, can you talk about a little bit of what are the hardware level attacks or IoT specific attacks which you have observed or which you want to talk about?
I'll give one example, which is very interesting one, but it's not very easy to perform that attack, which is called micro-probing. So basically there, what happens is PCB is subjected to examined using a microscope, and then they use various parameters, and then they perform, basically objective is to perform a reverse engineering of the whole thing. And then they try to clone the device to subvert those checks and controls if you already have. So that's primarily happened in a place where the value of that IoT device is pretty high. So in my area of work, which is on connected cars, that's something that I have noticed.
So can you talk about one hack on the connected car? So I think that will be very interesting to kind of deconstruct.
Okay, so I will talk about the very famous car hack done by on the Chrysler Jeep by two researchers, which is Charlie Miller and Chris Valasek. What they have done is, now it is nothing to do with this kind of sophistication or hardware hack. It was primarily the inherent lack of secure design, inherent lack of security in the network, in vehicle network, and certain configuration issues and some known vulnerability. These four together make the hack possible. So what they managed to do is he managed to get to inspect a ECU inside the car, which is electronic computing unit, and then he figured out that there is a service running which has a known vulnerability. So and it's a Linux-based device. So they managed to get into the device and then started observing what is known as CAN bus. So vehicle ECUs are connected using a CAN bus. CAN is a control area network, which by design it is not, there is no security primitives built into it because it's a real-time network, and that you cannot have overhead into it. Now, in CAN, unfortunately, no devices are authenticated. It just takes it. But there is some amount of checks given inside it, which is that not all the devices can write to CAN. So this person found out that there is one device in which the firmware is not checked by a root of trust. So he managed to get the thing out, and then he overwrote and rewrote the firmware, which then can write into the CAN. And by doing that, he has an access to powertrain modules, and he can send commands into it. Then he figured out we need an external attack vector to attach an attack vector, attack exploit to it. And then he found out there is an open Wi-Fi, which is for testing, which is opened. And then he managed to use his attack vector using that as a pivot. So the first attack was the car was running and he was driving in parallel, very close to about 100 meters. And then he managed to get the attack working. The next he thought that what if I want to do it remotely? And he figured out that in Verizon, in a cluster of network, you can actually do a scanning, IP address scanning, which will give you an IP address what is open. But you cannot do it directly. So he bought a picocell, and then using a known vulnerability, he changed the picocell, basically he routed the picocell. And using that, he scanned that network, and then after that, he got access to that Wi-Fi, and then from his basement, using his 4G network, he managed to hack the car, and he managed to crash the car. So that's the kind of anatomy of the.
So I remember, Chris, I think the time when we had dinner at Vegas in DEF CON, that was the same year when Charlie did this presentation. You were there at the presentation? Yeah, that was I mean, at that point of time, hacking a car wasn't like, you all know about it today. I mean, we all know that was like the first time they did it, which was a big sensation. So thanks for bringing that up. Arnab, anything else which you want to
I
talk
think we
about?
can go to the
Okay,
next one. Yeah.
perfect. So we were talking about the taxonomy, where basically IoT security is not really IoT security. It is the computer security or cyber security, what you call, is the same security. There's nothing new in this. The only new thing is that now, like suppose you are a soldier, you are fighting the same war as before. The only new thing is I tell you that I'm going to give you only 3 bullets, and you are not going to have the bulletproof vest and things like that. It's only the lack of resources, computing resources, which is different. But in terms of your threat actors, attacks, securing, it's exactly the same. There's nothing new. So if you think IoT security is new, it's actually not. And we are just committing exactly the same mistakes which we did in past in other context. So we spoke about application also. So somebody asked about how do we build secure software, right? Let's talk a little bit about building secure software, because software is a very important part of IoT, right? So anybody wants to take up how do you build secure software?
All right. I noticed that nobody wanted to grab the mic on this one, but yeah, so it's definitely a big challenge. And for me, I think one of the big challenges out there is when you get to those lower level devices, those lower level sensors. In the security industry, we have this tendency to, blame victims a lot. We've talked about that earlier today. And another thing is you'll hear people say, patch your stuff, encrypt everything. But, that's not always possible. We just had a mention of this CAN bus attack, and you're like, well, why don't you encrypt a CAN bus? You got to realize that this CAN bus has been around forever, and it's a very simple way of connecting things in your car, right? I just have one wire I can spare that runs out to a tire or something, and so I think what we have to do in terms of software security, again, it depends on which level you're at. If you're talking down at those little sensors, and a lot of these devices are not capable of things like encryption. If you look back a few years, I don't know if you guys heard about this J Maxx attack. I know this is old. It was it was the largest attack at that time. Of course, now it's like, that's nothing. But it was a big deal. And if you look at what actually happened there was a store, there was a J Maxx store that had bad encryption on their wireless network. They were using something called WEP, which today, people say WEP, that's really bad. But here's the reality. They were using WEP in their point of sale systems, and a lot of companies still use WEP in point of sale systems because the hardware isn't capable of anything better. And I think that's a big challenge when we look at IoT, is that a lot of these devices are just not capable of any serious encryption. So in terms of securing it, in terms of the software, I think what you have to do is develop a varying trust model, right? You have devices that are easily spoofed, that can't have any real kind of encryption involved. And what you have to do is have some sort of way of going the next level up in that system. Who talks to those devices? And they have to be sort of the gatekeeper, and you have to come up with some, nice logical ways of saying, how much do I trust the information that I'm getting from the sensor? And then, if you get up to those higher levels, then it's the stuff that we've been doing for a while, and people know that a little bit better.
So I think when we talk about the software, I don't want to take that as an isolated question. So I'll take one of the questions that was talking about, the entire end-to-end security. How do you have a secured IoT solution as such, while the software is still a part of it? As I was just mentioning, building a trust, right, is one of the key aspects. So while we talk about it, I'll bring in the topic of what we mean by chain of trust. So while we have this components as isolated, we have devices, we have gateways, we have cloud pieces, and all of those have been monitored. The chain of trust is one of the key aspects that usually should be talked about, because none of those components can be talked about isolatedly. I have a trust on my device, but my gateway is been snooped, or something of the security aspects which are not part of the cloud, which needs to be there, is not correctly configured out over there. So I think the chain of trust is one of the key aspects which needs to be built up in the entire end-to-end solution to have a secure IoT deployment to be done. And I think this security is something that should be talked about even before your architecture is being thought about. What is the security aspect that you want to build in while you are doing your architecture? Now coming on to the question, I think there are three different parts that I want to talk about from a trends perspective and from the applications security perspective as well. The first trend that I want to talk about is a layered security. We talked about a lot of that, and I'll just put that in different context out over here. When we talk about layered security, I'm talking about the security onto the hardware. I'm talking about security on the application side, and then I'm talking about security onto the communication side of it. The hardware security is all about the TPM, as just Bhaskar was mentioning about it. We have a trusted execution environment, we have root of trust, we have attestations been done onto the security layer, and that's on the gateway side where we have those security, which we see that this is a trusted device. We can attest it. We can have a secure storage within it so that the keys are stored in a secure environment, and isolated secure execution environment so that only the security keys and things are being thought through. The operating system is kept aside. We have a secured zone of talking to your applications which are secured enough. The second part of that is a cognitive layer of security. We have been talking about behavioral aspects. We have been talking about knowing the behaving patterns of the users, right? I'm talking about a cognitive security layer on top of this hardware, where we learn about the patterns of the use cases of this gateway. I mean, when this gateway has been used, what is the times that the gateway has been used, what is the kind of data that has been coming, or what is the average data that has been talked about. So when we talk about DDoS, I usually talk about a thin layer of anti-jamming layer, which will actually know beforehand, the kind of data that is being used or been sent by this particular gateway. And if that data has been moved beyond a particular threshold, we particularly move that particular gateway into a suspicious zone, and then have a context-based or a state machine-based deployment of a cognitive layer, which learns by itself continuously and also allows that learning to be passed on to its peers. So there was a context that we're talking about having peer-to-peer communication that he was talking about. And the peer-to-peer communication is something that we have been able to develop. We have a strong OT bus where the gateways are talking to each other, forming a peer-to-peer communication. What that happens, what that brings is a trust mechanism. We are allowing a beta of trust to be sent from one gateway to another. So if I'm talking to a particular gateway as a peer, I know that that particular gateway has already authenticated a particular device or a particular cloud authentication already been done, that beta has been created, that trust beta has been created, it's been shared between the gateways. So if I want to know about a particular device, I can actually go back and talk to my next peer, a neighborhood peer, and know whether this guy is to be trusted or not. And that beta is being shared across the mesh of devices or mesh of gateways. So here we're talking about the gateway security, we're talking cognitive layer of security. And then the communication configurations in the cloud needs to be very, very well corrected. And I think all the security aspects that are available in the cloud, as well as the encryption data, needs to be taken care of. This is the layered security I was talking about. We're coming out with another layer, which is called as blockchain IoT security. So here, again, the mesh of gateways that we are particularly forming are actually sending and making a blockchain. They are talking to each other and having a decentralized kind of environment where a contract has been signed between the gateways. And when the gateways are signing those particular contracts, a micro ledger has been sent out. So it becomes a public ledger to everybody. If anybody wants to do a DDoS attack, a particular gateway will be in position to see that you're not authenticated, but will also send that information to its peers, saying that somebody has asked me, but he is not authenticated as of now. Please check if the ledger that he has asked for, the hash that he has asked for, matches any of your hash. If that doesn't happen, we throw that particular guy out. So the probability of any DDoS attacks gets reduced. So we are bringing in this blockchain IoT security in couple of weeks from now, and there we are building a micro ledger. So here the application layer security of whitelisting a particular application, blacklisting a device, having authentications been done, knowing the patterns of the usage of a gateway is something that are key in this particular chain of trust that has been brought about. So I think that's where I want to talk about. Another aspect of chain of trust is not about only the devices over here. I think one trend that has been set out and but talked about mostly is supply chain trust. So if I'm a vendor, I'm taking component from somebody else, I don't know whether that component itself has a vulnerability in it. I don't have, did not make any check on the software that has been sent by him to me has any vulnerabilities in it. So I think the key aspect of even making this chain of trust continuously going is also to know and put some contract in between, relook at your contractors. Don't trust your suppliers as they are wrong. In the IoT world, you need to put out some kind of a changes in your procurement process to know and put some testings that been done by your guys and get those testings been done. He was talking about CSVs, the vulnerabilities and the scores that are there. I think you need to move back, go into your software, know the kind of the severities of the vulnerabilities that are already present, get a score out of that, and allow your suppliers to know that we will not take your software unless and until you meet these kinds of requirements on CSVs or the vulnerabilities that are there. This particular trust score is required from you before we take those softwares. If you look at the code, if you look at the open source that we're using, I think supply chain again makes a lot of sense over there, because open source codes have a lot of vulnerabilities, and you don't know whether those vulnerabilities will be the key aspects of the attacks that are going to happen going forward. So having a supply chain is again building that particular chain of trust. So I talked about three things. One is the layered security, I talked about blockchain security, and then we moved on to talking about the supply chain. So that's a trend that I'm looking at, and that's something from me. Thank you.
So I think the question was on software security. What do we do for that? Okay, I think some of these standards have emerged for really secure applications, like common criteria for smart cards on one side, NIST security, for certain key transactions and so on. So I think we there are guidelines for how do we write software for such applications. For example, in common criteria, when we were doing smart card readers and RFID readers, the pin pad reader, it will be verified by a auditor whether this code is having any vulnerability, that the last pin which was pressed by the user is cleared before the next transaction. So there is a certain guidelines for development, and there is a validation or certification for implementing such a security. So I think these concepts need to be moving into the IoT domain in order to provide our software. What we write is also that level of security. That I think is what we can do. Then if you take the world already, if you take aerospace, if you take railways, they already implement what is called safety integrity levels. So, and they don't go and overboard and say for everything there is a highest level of security. It depends on the particular, if it's a lighting or a fan in or AC in aircraft, there's a different level of security software integrity level we check. Whereas if it is something which is results in fatality, that's a higher level of safety level. So these are categorized, and there are software tools available from many companies, where our code can be put in. Of course, they are not simple microcontrollers, a little more high level of some RTOS, etc. With that, you can actually evaluate with this tool that how secure is our code, or how what are the vulnerabilities possible, what are the code paths which are not okay, there are no error paths are not validated. So all of that is tested, and these are the vulnerabilities finally which will come out. A hacker can see, yes, this error path is not covered, so he can get in there in his code when he wants to do that. That is on software security. Then there is also an element of in an embedded device. When we talk about the end device, there is a code which is residing there, right? So how do we protect that code? How do we ensure that nobody can come and write a new code altogether? And of course, there is other aspects of it that is we'll talk about other encryption part. But the key is that we want to be able to update the security levels because it's an emerging thing. So we want to be able to add some new security features maybe to the code on one side, and then at the same time we don't want somebody to update the software with something else and the device is doing something else. So this is the trade-off. And again, using our technologies like TPM, we can implement safe software which is difficult to hack. We will talk about a little more on hardware.
So I think that's wonderful. So we covered some of the strategies. I'll be slightly prescriptive and add a little bit more, which is going to be very operationally prescriptive. I don't know if you need a prescriptive solution or not, but I'll do that. So if some of you find it useful, you can just go back and check. So see, there are two parts of software security. Okay, one is building a secure software, and second is running a secure software. Okay, these are two different parts. Operations and building, two different parts. Now, combining these two, we can have a application security program. Okay, so I'll tell you how to build an application security program. So if you have to build a program where you want to build secure software and run it operationally, what are the aspects you should look for? So I'll start with building. So one is for an overall framework for this, look at something called OpenSAM, OPENSAMM. So OpenSAM is a framework which lists around 80 or 90 activities that you need to do. So obviously you can't cover all, but I'll give you a high level idea so that you understand what are the kind of elements which are there. So one is secure design. So in that secure design, you need to do secure architecture review, threat modeling, that's one. Then comes development. During the development phase, you need to do the testing, and for the testing, there are various types of testing called static application security testing, dynamic application security testing, and then there's a new thing which is interactive application security testing. And then with fast releases, you now need to have secure DevOps. So SecDevOps now happens in a slightly different way. So you can go back and look into areas like SecDevOps as well as API security. These are two new things which are coming up in the application security space. So you need to build security in the early stage and have something what we call as the secure SDLC. So that's one part. And in the operational phase, there are many aspects which are there. So you can look at the NIST framework, where you will see that there are 5 types of controls called identify, protect, detect, respond, and recover. So for each of these 5, there are some 100 types of activities and some 1,000 types of sub-activities that you can do. But at a broad strategy, you need to look at these 5 types of capabilities. Now, somebody asked about, I think over there a gentleman asked, like, I have to, use all these IoT systems and put a IoT infrastructure together. What do I look for? So the NIST framework is a good framework to look at from the strategic perspective, but you will have to customize the activities specifically for the IoT context. I think for IoT, there are some other frameworks which I can't recall. So at a broad level, these are the things. Now, this is a very vast area. There can be a 5-day workshop on this. I don't know how much we can discuss right now, but at a broad level, these are the pointers. So those who seriously need this, if you can just use these pointers which I mentioned, and you will be able to find out all the things which are required to be done in that. The biggest problem will be prioritization, because you will not be able to do all this stuff, so you have to select a few. That's where you will need maybe expert advice from security experts and things like that. So that's at a broad level on the, I think, building secure software as well as running software security. We'll come back to the second part which we spoke about, which was about the security controls for IoT. And I think some of those you already mentioned, right? So what we'll do is, we already covered a part of part 2 in part 1. And that's absolutely fine. What we can do is just revisit and see that are we missing certain other things? Are there some IoT security controls which we should have, and what are going to be those? So Arnab, would you like to talk about some of the IoT security controls which you suggest?
Yeah. So just to take from your discussion regarding a little bit of a prescriptive. One very important aspect when you build software for IoT world is a change of mindset. If you look at application security nowadays, you normally don't a little bit care about the underlying hardware that details. So here you actually have to think about more. But is IoT all about understanding the underlying hardware? No, there are layers. So if you the closer you are to the device level, it is more towards the domain, and then there are domain specific standards which are evolving. So if you talk about industrial automation, there are some very well defined standards, and then they define the controls. Then SAE J3061 is for automotive. They define the controls and some of the checks and balances for those kind of IoT kind of things. Rest are evolving now. Medical electronics has a very strong FDA recommendations for but FDA is audit requirement. It's not a technical control requirement though. But these are the three areas which is probably more mature in terms of telling you a little more the what you should do. The rest of the areas are just coming up.
Yeah, thinking about controls, one of the things kind of occurs to me is, certainly there's more things that we can do, and as has been mentioned, often it's a priority thing. It's not a priority for somebody that's developing an IoT product to build in certain security controls. I think of the skydiving industry. This is kind of an interesting example. If you look at helmets, if you look at safety standards, they say that all skydivers should wear a hard helmet. Most of those helmets are made out of plastic, right? So they don't give you any really effective protection. Yeah, sure, if you bump your head on the door on the way out, it might help a little bit, or keeps the wind out of your face if you have a nice full face helmet. But the reality is, it's not the same thing. So like if you compare it to say a motorcycle helmet, there's legal standards, right? You have to provide certain levels of protection for the rider. And when it comes to skydiving helmets, there's no regulation there. So I think in terms of seeing some of these controls put in place and seeing that priority, I think it's going to have to be something that's driven either by the consumer market. They're going to have to start demanding that some security controls be built into their devices, or perhaps, I hate to say this because I don't really like government getting involved in things, but maybe it is something that the governments do have to get involved in.
And one question for you, are you seeing, like in the academia, is there specific research happening on IoT forensics?
Not that I'm aware of, actually. So there's not a lot of, in academia in terms of computer digital forensics, there's really not a lot going on there. As I mentioned before, my university is one of 6 that has the NSA SEAL Center of Academic Excellence stamps in forensics. But there's just not a lot of people out there studying forensics at an academic level.
That's very interesting. Like one thing which the security world had been trying very hard all these decades was to protect. But we now know that we cannot protect. I mean, we will get breached. You have to build a security program considering that you will be breached. So security is very much like happiness. And whatever you do, I mean, one is happiness is very fuzzy. You can't measure. You don't know how a lot about it. It's very fuzzy. But secondly, whatever you do, you can't always be happy, right? And a generally happy person will go through those moments of sadness, but will recover. And a generally sad person will always remain sad, will never recover, right? So I think in security, philosophically, we need to have a similar approach where if you can bounce back from an incident, okay, there can be a security breach, but will your business be affected? That's the question. So that is the reason why we need to have the response and recovery as a very, very critical part of building your security program. So in terms of the response program, one of the key elements is forensics. And this is something very interesting that even in the US universities, which we consider like as the foremost in cybersecurity, even there the research is limited, right? So, so we are actually a long way to go in terms of building the response and recovery as a capability in security. So if those entrepreneurs who are there want to do something, and this is an opportunity, right?
Thanks. I think the definitely there is a lot of work to be done. In case of a breach, what are the response and other actions. But however, I think we can try to prevent. That is what there are technologies or options available today to improve the security level and make sure that our devices are as secure. To give you an example, our cell phones have SIM, right? So fairly secure. So although there's a keys, private keys, which are stored, same keys are stored in two places, one with our cell operator and one with us. And till today, it's not been easy that people have hacked that. So that technology is being moved into, when we talk about connected device level security, so that the keys and the whole authentication process between the end application and the connected device is happening in that level of a security. That means the smart card, which is the chip which is there in the phones, etc. Same technology is being brought into the connected device, where along with the microcontroller we can attach a small device. They come with various levels of security. Again, some just hashing algorithm, some with AES, some with the TPM. So this way, when we connect a microcontroller and this device, and then we have a secure way of provisioning and registering these, pairing these devices, these secure chips, then we have end-to-end security. That means three important aspects are there in security. One is authentication. That means we want to make sure that yes, the right guy is there. So, and we know passwords are shaky, they can be spoofed, they can be sniffed, they can be picked up from somewhere. So therefore, instead of the password, the keys which are stored securely in these devices. In fact, I think he talked about even X-ray or any other way of there are other attacks like electrical voltage attacks, etc., by which we can maybe pick up from a normal memory storage of data or a key. But these smart card or these chips which are secure chips which are coming out, they have actually also made in the fabrication itself, they have made it a complex that a hacker cannot read in the code which is secure, key which is present. So authentication is important. Then there is confidentiality. That means we don't want the data transaction which is happening to be viewed by someone, because today he may view it and use it in some other context, right? So therefore privacy issues are also there. So confidentiality means we need to provide some encryption. Data has to be put it encoded in a manner that it cannot be hacked or picked up in the transit. Then most importantly, integrity. This is what causes the actual havoc in IoT. If in case the integrity is compromised and we're not detecting it, then we can have a boiler which is overflowing, or we can have some entire smart city clogged and jammed. Okay, so therefore the integrity of the data validation is important. That means whatever is receiving, that integrity is also maintained. So these are all going to be available today once we have this smart chips. A couple of semiconductor vendors already announced, and they are all available for fairly reasonably priced also. So that's the way I think at a device level security will come. And this, what we talked about, trusted platform, is also a standard from the trusted computing group, and therefore there's some X.015 some standard already in place, so that end-to-end security for devices is possible. Thank you.
That's a very good question. What is the controls that we want to put out? So I'll relate this to a question that was asked by an industry automation customer to us. You guys are actually doing a lot of things to make the end-to-end security aspects. But when I want to deploy these IoT solutions, one of the key aspects is a response. I have a DRM system, a disaster recovery management system in the IT. But if your gateway goes down, I have a single point of failure. How do I get out of this? What is the response that I should go? And I don't know if this deployment is really going to work out. We are talking about an area where we want a 99.99% availability on the cloud. And if your gateway goes down, I don't know how much kind of availability I'm going to get. And when this question was posed to us, the response that we gave, I'll just let you know about what the response was. So we gave it, we thought through this, we worked on that, and then we gave him response that, we can have a resilience mechanisms within the gateways that we are providing you, though the chain of trust is already put in. And even after that, if there is an attack, you see that there's a security breach, or the cognitive layer that we have put out is telling you that there's a suspicious mechanism that is happening onto the gateway. We will be in a position to configure, and we will allow you to configure another gateway, which can be a separate gateway altogether, or there's a dockerized mechanism of having two gateways onto the same hardware. If the hardware is actually compromised, you can move the devices and applications from that gateway to another gateway seamlessly, so your operations actually continue, you have a high availability going on. So we try to bring those terms of high availability, resilience mechanisms from the IT world into the OT world. So the clustering of gateways is something that we are trying to make up, because the gateways are in a mesh of networks. So that's the resilience mechanism and the response that needs to be put out. And the companies can use that particular resilience mechanism as a response if there is an attack altogether.
Wonderful, great. So we have just a few more minutes left. Any questions?
Standards you refer, or
So I think the response would be from my side at least. There has been a security is the trust that he was just talking about. We can actually measure the vulnerabilities that are continuously going on. So response have to be adaptive. So cognitive layer that I was talking about should be adaptable to upcoming threats that are there. So we have a CIF, which is security.
So I'll try to address this. So the answer to this question is that until some time back, there wasn't much work happening in this space. So I did not introduce like what does my new startup do. I just told the name. Very interestingly, we do the benchmarking. Okay, and that is something quite new at RSA USA this year. We got chosen as among the top 40 innovations. I don't know of too many guys doing that, but I'll give you some idea of how to do benchmarking. Okay, but forget like whether you use a tool or a product or not. So the way you can do benchmarking is through two mechanisms. One is external and the other is internal. External, how do you do benchmarking? By getting open source intelligence. So how do you get open source intelligence on this? So now there are a certain set of companies like BitSight and security scorecard, etc. They can get external intelligence and give you a cybersecurity score. So you will know the cybersecurity score of yourself, but you may not know for the rest of the peers in the industry. Or I don't know if they do it. So that is one mechanism by which you can do. The other is internal, where you look at what kind of controls do you have, and how does the other peers in the industry do that, and then you have a benchmark. So we actually built a benchmarking product as the new venture. We don't do it specifically for IoT. So for your specific thing, we actually don't do it. But the same methodology can be used. So if you have to do that, what a kind of initiative that can happen is like from TIE IoT, this thing, you create a group of organizations where you share data point. And you build this data point that, okay, these organizations have this kind of data controls, already established, and then you build this repository which can be used later on. You can do this as a community initiative and drive something like this. So to give an answer, there is a way to do it, but there's no clear-cut solution right now for IoT. Does that answer your question? Okay, perfect. Any other question? Patch management?
Yeah. Like as you said, there are a lot of CVs that are coming. Maybe
Yes.
it may be applicable or not. Like it may be a lot of false positive for my device. But if I have to apply the patches, I can't just keep looking into patches and then see. So there should be some mechanism. Is there any mechanism where I say this is my device, embedded device? Okay, detect those versions and then just push the patches and then try to see some compilation, or I mean something. But I don't see right now such thing. Is there anything like that?
Anybody wants to take this?
Yeah, you're right. There is this is a very new area of solutioning. So again, I would say it's very domain specific. For example, if you look at for automotive domain, there's a whole set of products which are doing OTA, over the air update. and they use a chain bootloader to make sure that they are actually getting the right software. For industrial automation, the same thing has started happening. They are using not OTA, but a similar mechanism to push updates quite regularly. But yes, patching is probably one of the biggest challenge in IoT. So in a larger industry, it is easier. But for a smaller, firm where you have many, hard level sensor devices, most of the cases they are not patched. And if you see this Mirai botnet had actually utilized one of those known vulnerabilities inside it.
So patch management is actually a difficult problem even for large enterprise, despite the fact that patch management solution is available for over a decade. And the reason is that once you apply patch, functionality breaks. So even though technically you see that all these systems and solutions are available, organizations are not able to patch effectively. So when we do benchmarking, this is one of the biggest challenges which even large mature organizations face today. Now for IoT, it makes it harder. So are there patch management solutions? It is there. Are there processes to deploy it effectively? That is also there, but it needs to be a very well managed program where you deploy the patch in test environment, make sure test environment really represents the actual environment, and you should have the enough confidence that you are able to push it. So pushing the patches automatically, you can do it. The challenge is things will break. So if you build an effective patch management program where all these things are done systematically, technologically it is possible. Now, the other thing is, in a lot of cases, once you see that, okay, I want to deploy this patch, the moment you do that, your functionality breaks, applications don't work, then what do you do? So I'll give that answer. I know you did not ask that question, but the moment you start patch management, you'll face this question. So what you need to do is called compensatory controls. How do you build compensatory controls? That is, like you see that, well, I have this vulnerability, which is unpatched. So if I have this vulnerability, which is unpatched, then at the network level, I can find out packets which will try to exploit this vulnerability, and I will drop those. Okay, so it's like a virtual patching. You can do virtual patching at the network level. You can do virtual patching at the application level. So this is one. So before it reaches, you drop them. The second kind of compensatory control could be that moment you see things like this, there are solutions which are called SIEM and Security Analytics and Security Operations Center. You create new rules which are fed specifically for the vulnerability which you are aware of and you haven't patched, so that a trigger or an alert gets generated immediately, and things like that. So there are patch management solutions, but you will not be able to always patch. If you cannot patch, please use compensatory controls. That's the one-liner summary. Any other question? Last question maybe, and then we'll move on. Okay, so we'll not take the last question. We'll close with this.
No, I think especially at the embedded, at the end level, the power is an important factor for doing any software updates, because the battery life is, maybe it will supposed to last for 3 years or 2 years, based on maybe sending 10 bytes of data every hour or every 12 hours. And the moment we say, we want to update the firmware in the device, so maybe the entire battery life will be gone. So this is another, aspect to be considered.
Great. So thanks. I think our time is up. Before
Thank
you could
you.
throw us out,
So,
I
no,
close this.
I'll just make sure the lunch has to start.
Okay. So thanks everybody, and thanks all of you. Thank you very much.
Yeah.